So we're recording. I'm going over homework number 8. Showing number 39 on the 6.4 homework. I don't know what page number that is. Actually, page number is 311. There we go. So he has to integrate r plus 1 squared with the limits of -1 and 1. So I would actually do this first. I would expand that to make it r squared plus 2r plus 1 dr. And the antiderivative, remember, you're going to add 1 to the exponent and divide by a new exponent. So I'm going to do r cubed over 3 plus 2r squared over 2 plus r. Don't worry about the plus c because it can cancel anyway. And you're going to plug in -1 and 1. So here I'm using fundamental theorem calculus part 2. Part 2 of the fundamental theorem calculus in the antiderivative and plugging my limits. If you plug in correctly, you should get 1/3 plus 1, because those 2's are going to cancel, right? And plus 1 again. And if I plug in -1, I get -1/3 plus 1 and then plus -1. And then it goes, of course, I'm subtracting these bad boys. Well, that's going to be 8/3, I believe. Wait. No. Hold on. 7/3. Is that right? Okay. I just can't do math today. Sorry. Let's take 2. When I plug in 1, yes, I get 1/3. I get 1 and 1, right? Subtract that when I plug in -1. I get -1/3. Still plus 1, but then -1. So those are going to cancel. So now I got 7/3 minus -1/3. And that's why you get 8/3. So be careful of all the negatives. I almost made a mistake myself. But that's all. And remember, 1 and 1 are 3 and 3 over 3. So 1 plus 1 is 2, that becomes 6/3 plus 1/3, 7/3. 7/3 minus -1/3 is 8/3. 41. You have 2 minus x. So find the total area of the region between the curve and the x-axis. Okay, no problem. What you got to do is, might help to graph it. If you plug in 0, you get 2. If you plug in 2, you get 0. And you plug in 3, you get -1. So that's going to be 2, right? Because you do 1/2 times base times height. This area is going to be -0.5. But you want the total area, so you got to make that positive. That's why it's 2.5. So you can just use geometry to solve that one. That'd been fine. Or you could use your calculator, where you do from 0 to 3, with the absolute value of 2 minus x dx. And remember, doing the calculator, go to alpha and then window. And there you'll find absolute value and the actual function for doing a integral in the calculator. So just so you know, it's all right there. It's your one-stop shop for this stuff. Alpha window, you find all the features you need to do this stuff. Okay, I am going to hit up 57, 59 just a little bit, but someone's asked about 5 and 9 here. For number 5, so these problems here, you simply have to find the antiderivative of these. So the antiderivative of 5 to the x times ln 5 is just 5 to the x. The reason why is because if we look at our cheat sheet again, right? Remember, we have derivative of a to the x. It's a to the x times ln a. So if you have a to the x times ln a, to go backwards to do antiderivative, just a to the x. So in this case, our a was 5, right? Yeah, our a was 5, so you have 5 to the x. That's it. And then you have 1 over x squared plus 1. So you just use your cheat sheet. When you see that, you assume it's just going to be inverse tan x. That's all. So easy peasy. And then plus c, right? So number 9. Yeah, when you see secant squared, you should know that's going to be tangent, because the derivative tangent is secant squared. And you kind of just leave it like that. And then you kind of just see by intuition, okay, what if that's my answer? If I take the derivative of that, I do get secant squared x to the 5th power, but then I do derivative x to the 5th, which is 5x4. And so that works out also. And derivative of c, of course, is 0. So that's that one. Now 57, this is a problem I love. The College Board loves it too. The first one's pretty easy. Just plug in 0, you get 0. Done, right? Remember, was h increasing? Well, you want h prime of x to be positive. What's h prime of x? It's going to be f of x. And so f of x is positive from 0 to 6. Actually include 0. But you don't include 6 because obviously f is not positive at 6. So you do a bracket at 0 for parentheses 6. So there, we actually do care about the brackets of parentheses because f is not positive at x equals to 0. And remember, h prime is f based upon doing the FTC here that we've talked about. Variable is concave up. So in this case, we want h double prime to be positive. Well, h double prime of x equals f prime of x. So in this case, I need f prime to be positive. That's definitely be positive from, hard to tell, but I'm going to say probably from 9 to 12 because your tangent lines are positive there. So, and you keep those open. Actually, you can close the 12, but you do the 9 as a parentheses because obviously if you're assuming it's 9, I would tell you if there's a horizontal tangent there, by the way. If there's a horizontal tangent there, your second derivative for h or your first derivative f is not positive. It's 0, but it's positive after that. H12, so what we have to do is we have to now integrate this, H12, so you go from 0 to 12. Well, I suspect that this is a bigger area than that one. So that's why I say it's positive. I'll just use an area kind of explanation for that one. And actually, let's look at the Ansky. Let's see what the Ansky says. Also good to make sure I got the other ones right too. Yeah, 0. Yeah, increasing from, not sure why they include the 6 though. That doesn't make too much sense to me. That 6 should not be included. Concave up, it looks like an open interval. The 12 should be included. Anyway, it's positive, there's more area above the x than below. That's the explanation there. For E, where does h achieve its maximum value? So my guess is will be at x equals 6 because after 6 you start accumulating negative area. And where does it achieve its minimum value? I would say at 12 because you've accumulated as much negative area as you can over there. So that's just using more like an explanation for intuition more than anything else. Of course, it helps to find where you have your critical points. And remember, h prime is f. H prime is 0 or f is 0 at 6 and 12. And your f is positive here. Remember, h prime is f. F is negative here. So clearly you're seeing a change for the sign of f or the sign of h prime at 6. And that's going to be a relative min there. And then relative max at 6 and relative min at 12. Oh, wait 1 sec. I lied for f. I lied. It is a relative min at 12, but it's still a positive area. It's going to be 0 because we had 0 area when you integrate from 0 to 0. So my bad. For f, it's 0 because that's the lowest one you can get. Whereas if you go to 12, it was still a positive area as we'd said for part D. So my apologies for not recognizing that. So that's how you kind of explain those problems. 59 is using a little bit of linear motion. And I guess this is, using the instructions up here. This is a position function. Never mind, sorry. That's incorrect. S prime equals f, and S double prime equals f prime. So your position function is the integral of that graph. So in this case, then, the graph itself is S prime, which is velocity, by the way. And this, by the way, we know is acceleration. The position itself is the accumulation of the area for the graph of F. So that's what you have to look at it. Yeah, they love doing this on the AP as well. We say they have a College Board. So this is the graph of F or S prime or V, velocity, because S prime is velocity. So what's the product of velocity at t equals 3? Well, yeah, S prime at 3 equals F at 3. Remember, S prime equals F, and S double prime equals F prime. So you just plug 3 straight up, and that's it. You get 0. This expression, positive or negative. So you're doing the derivative here, which of course is positive, because S double prime is F prime, and it's a positive slope there. What's the particle position at t equals 3? That's just finding the area, which is the right triangle. Looks like the bases are, or the dimensions are 3 and 6, but take half of it. So you should get -9, I believe, for that one. Let's look at the answer key. Yep, -9 units. For D, when does a particle pass through the origin? So basically, when your position is 0, definitely at 0 itself, but also at 6, because these areas are going to cancel from 0 to 6, because from 0 to 3, it's -9, and from 3 to 6, it's +9. So I would gather at 6 also. The passes, so your area, your position, because remember S equals F, the integral of F, right? And so that's where I think our position would be 0 at that place. Yep. 0 also, I don't know why they didn't include that, but maybe they wanted something that's non-zero, or I'm not sure if they defined as an open interval after 0. But anyway, when is the acceleration 0? So that's when F prime is 0. F prime is 0 right here at that peak. So that probably looks like at 7, looks like. Yep. And then F, when is the particle moving toward the origin? So it's moving toward the origin when your position is positive, but your velocity is negative. Or when your position is negative and your velocity is positive. Well, here, in this entire region, our position is negative, because we have negative area. And our velocity is also negative, because velocity is the y values, right? Remember, velocity is S prime equals F. So that's going away, definitely over here. Now here, you still have negative position until you get to 6, but your velocity is now positive, so it's going towards over here. And then all of a sudden, your S is positive, and your velocity is also positive because you're above the x-axis. Because remember, S prime is V and S prime is F. So we're going away from 0 to 3 and 6 to 9, but we're going towards from 3 to 6. Because you're going towards when your position is to the left, but your velocity is positive, you're going back in the other direction. But you're going away, if your position is negative, velocity is negative, you keep going further out. And likewise from 6 to 9. And I think that's what they have right there. Moving toward from 3 to 6. Yep. Mm-hmm. Yep. That's exactly what they got. Then finally for G, on which side of the origin does the particle lie at time t equals 9? Well, now in this case, we have all positive position, and our velocity is positive. We're totally to the right of the origin, right? I mean, our area is positive there. Yeah, on the positive side, because our integral is going to be greater than 0. The area below the x-axis is smaller than the area above the x-axis. We can just kind of estimate that. Well, we know that's -9, and that cancels out with from 3 to 6, that area. That was, we did it for part D. And then, of course, you have more positive area from 6 to 9. Okay, that was a lot to talk about. If you still have questions, you could talk to us during office hours tomorrow. I will be available at 8:15 tomorrow for office hours with Ms. Vox. So, and of course, we'll do lots of review on this stuff tomorrow as well. We'll do a lot of FTC style type of problems. I think that's important. So now let me stop the recording.